Hello and welcome to this video in which we shall discuss how to find the domain algebraically. So the domain normally is all real numbers, and we have two exceptions. We have x in the denominator, or if we have x under the root. So if x is in the denominator, then we write x is not equal to 0, because the denominator can never be 0. If we have x under the root, so we have to write x is greater than or equal to 0, because you can never have a negative under the root as long as you're dealing with real numbers. So what if you have x in the denominator and under the root as well? So because it belongs to the denominator, so x can never be 0. And because it's under a root, so x is greater than or equal 0. If you combine these two conditions together, you get x has to be greater than 0. In other words, this tells us it cannot be 0. This here tells us that it cannot be negative. So if it cannot be 0 and it cannot be negative, then it must only be positive numbers. So not 0 and not negative. So in this case, it has to be a positive number. So for this question here, we are dealing with the second case where we have a root. However, under the root, we don't have x, we have an expression of x. So instead of x greater than or equal to 0, we're just going to write the expression and solve. We have 8x minus 56 is greater than or equal to 0. We take the 56 to the other side. So we have 8x greater than or equal to 56. Divide by 8, divide by 8. You get x greater than or equal to 7. So our answer here is going to be x is greater than or equal to 7. So again, for this problem, we have the second case, which is similar to root x. And we said that x can be 0 or positive. So x is greater than or equal to 0. Now let's apply this here. So we have negative 42 minus 6x greater than or equal to 0. You can take the negative 42 to the other side. So we get negative 6x greater than or equal positive 42. And then we can divide both sides by a negative 6. However, if you're multiplying or dividing by a negative, you have to change the inequality sign. So it becomes x is less than or equal negative 7. Another way we could have solved this looks as follows. We have negative 42 minus 6x greater than or equal 0. You could have just taken this term to the other side with a plus. So we have negative 42 greater than or equal 6x. Now we divide by positive 6. And we have negative 7 greater than or equal to x. So we only switch the sign if the division is by a negative number. That's why we did it on the right, but we did not do it on the left. We did it in the green part here. We changed the inequality sign because of this negative sign. However, here the divisor is a positive number, so we did not have to change the inequality sign. And note that we got the same exact answer in both. So in both cases, x is less than or equal negative 7. So this is similar to the one we just solved. We have negative 45 minus 9x greater than or equal 0. Take the 45 to the other side. You get negative 9x greater than or equal positive 45. Divide by negative 9 on both sides. You get x less than or equal negative 5. One last problem. Here we have 6 minus 2x greater than or equal 0. We take the 2x to the other side. I'm just trying a different approach so that you know both approaches work. So here we have 6 greater than or equal to 2x. Divide by 2, divide by 2. You get 3 greater than or equal to x. This is, of course, exactly the same as x is less than or equal to 3. These both mean exactly the same thing. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.